everyone, so in the last video we talked about 3 ways to calculate a measure of spread, how spread out your data is. We did range, interquartile range, and mean absolute deviation. In this video we're going to talk about one more way to measure how spread out your data is, and that is standard deviation. So basically we can do better than mean absolute deviation. So here's an example. Imagine we have the data 4, 4, negative 4, negative 4. So these are, well, imagine those are your deviations anyway. So like this data is 4 away from the mean and negative 4 from the mean. And so if we were doing mean absolute deviation, we would just find the absolute value and then we'd add them up and divide by 4 and we'd get 4 basically. This one, imagine you've got data that's like 7 away from the mean and 1 away from the mean and negative 6 away from the mean and negative 2 away from the mean. If I calculated that one's mean absolute deviation, we would also get 4. However, it's pretty clear that this one is a little more spread out than this one is. It's kind of more all over the place. And so this one should have a slightly higher number representing its spread than this one. So mean absolute deviation isn't maybe the best option for measuring spread. So a slightly better option is standard deviation. It's basically the same thing as mean absolute deviation, except for you take all those deviations and you square them, and then you divide by 4, and then you actually square root at the end. When we do this one is still going to be 4, but this one's going to be 4.74, which shows me that it's slightly more spread out than this one is. So that's standard deviation. Here's kind of the steps. You find the mean, and again, like before, take each number, subtract the mean, and then you actually square the result. You don't have to do absolute value in this case because when you square it, it turns positive anyway. So we square it, then we find the mean of all those squared differences. At this point, this is actually something called the variance. And then at the very end, you take the square root, kind of to go back to the like before we squared everything. Some symbols here. This symbol is called sigma. It's a Greek letter. It stands for standard deviation. And so sigma squared, like before you take the square root, is variance. Because if I were to square root that and get the final answer, that would be sigma, standard deviation. Let me show you an example. So imagine we measure some dogs, and here are their heights. All these different millimeter measurements. I want to find the variance and standard deviation. So here's the numbers that I've got. First thing I'll do is find the mean, which we call x bar. So add them up and divide by 1, 2, 3, 4, 5. There's 5 of them. So do 600 plus 470 plus 170 plus 430 plus 300, and then divide by 5. So the mean is 394 millimeters. That's kind of the middle of this data here. And now I just want to see how far are each of these data points from that mean. So when I take 600 and I subtract the mean, what do I get? And when I take 470 and I subtract the mean, what do I get? And when I take 170 and subtract the mean, and 430 and 300. This is pretty tedious, not gonna lie. Okay, I'm just gonna do all this here. So this is 206. This one is 76. This one is negative 224. This one is 36. And this one's negative 94. Oh, I should have done that. And so these are the deviations. It's how much the data points deviate from the mean. How far are they from the mean? Like this one is 76 from the mean. Okay, so now we're actually going to square each of them. So do 206 squared and 76 squared and negative 224 squared, which is going to come out positive, so you honestly don't need to put the negative, and 36 squared and negative 94 squared. And then, once I get all the squared stuff, I'm going to add them up and divide by 5, because there are 5 of them. So I'm going to kind of do all that at once. So 206 squared plus 76 squared plus 224 squared plus 36 squared plus 94 squared, which gives you 108,520, and then divided by 5, and we get 21,704. This right here is the variance, so we'll call that sigma squared. That's part of this. If I want to get from here to the standard deviation, I just square root it. So if I do the square root of 21,704, I get 147.32 approximately. And that is my standard deviation. There we go. Basically, this kind of tells you how much each of these are away from the mean. All right. Let's try another one. So in this one, go ahead and again calculate the mean to start off with. Add them up and divide by 6. Okay. And I would pause the video and then you can watch me go over this. So total I got 600, and divided by 6 you get 100. The mean is a nice 100. Now I want to see how far each of these from that mean. So if I take 75 minus 100, do 83 minus 100, 96 minus 100, 100 minus 100, 121 minus 100, and 125. This is pretty easy. That one's 25 away, well, negative 25, but you're going to make it positive eventually anyway. This one is 17 away, that one's 4 away, that one's 0 away, this one's 21, and that's 25. All right, then I'm going to square them all, and then find the average of these. So add them up and divide by 6. When you do that, you should get, where did it go? Should get 332.6 repeating. That's your variance. And if you want the standard deviation, you just square root this, which should be about about 18.24 approximately. So that's your standard deviation. Notice this one had a much higher standard deviation, 147, than this one did, 18. So this one is way closer together. It's much less spread out than the past problem we did. All right, so that is standard deviation, and you actually, a couple disclaimers. First of all, you usually don't have to do this by hand. You can do it in the calculator or in some sort of spreadsheet or some sort of calculator tool online. So that's pretty helpful. Also, we've been assuming here that you know the entire population. In further statistics classes, you might not know the whole population, and so the way you calculate standard deviation is a little different in that case, so just be aware of that.